I'm Sam with Revolution Machine Tools, and this is the B-Genius press brake. This B-Genius has a lot of cool features to it. It's got extra axes control on the back gauge, multiple fingers per back gauge section, and then we've got an automatic tool clamping system. This press brake right now actually has segmented dies on it, but depending on what you end up picking, you could go with longer sections, you get a whole bunch of these small little segments here, and you can build whatever stations you need for your part. Let's go over the control real quick. Almost all of the RMT press brakes come with a Delem control, whether it's going to be a 60 series or a 50 series, whether it be a 66 or a 69, and they all just have different versatilities that are available to them. So depending on what your needs are, we can get you the right control for it. This control here, we've got multiple buttons across the top row. We've got the hydraulic system here, the hydraulic stop, hydraulic start, and that's for on and off of your hydraulic pump. We also have hybrids, which are a servo-driven hydraulic system, or we have an electric brake, which uses no hydraulics at all. It's band-driven, actually. Here we have a reset button. Anytime you have any changes on your NC control, or if you run into a safety error, because this has all sorts of safety features to help protect you from getting injured, there's a reset button. If this is blinking, then you have to hit the reset button to clear it, and then your NC start to get it going again, all right? Box bending. Many of you guys will bend parts where you have an obstruction come up, and because this has a safety system in it to protect you, if there's an obstruction, and your safety laser goes through, it's gonna halt the machine. And there's something like a box bending button or a two-step process so you can push down past obstructions when required. ACAS adjust mode. This switch is so that you can make sure that you line up your safety system across the bottom of the punch to the receiver on the other side. So transmitter, punch, receiver. Make sure that they're lined up and that the 3 receiver holes are filled with light so that you're ready to go when you're running safe, okay? Once that's been done, you've got to turn off your ACAS light because otherwise your safety system is blinded. Overrun lamp. Anytime I have my ramp up in an upper position, that overrun lamp button will either be flashing or solid. Here's your clamping switch. We just talked about the automatic clamping system here on the top. What it's actually got is a hydraulic bladder in here that causes those tools to, these little grips in here to pinch down on the tool and hold it nice and seamless across the bottom and firm in your machine so you don't have to worry about it damaging the tool when you're pressing. If I turn it off, my tools are loose. I can slide them out and put new tools in and then reclamp it once I'm ready. Pump kicks on, and now my tools are nice and firm again. There's 2 different clamping systems on there. This clamping OK button is actually for a different type of clamp switch than this one. This one's got both the light and the switch pushed into the same button on this specific machine, but usually it would be a black switch like this and light up your clamping OK. Slow up. Every once in a while you actually need the ram to move up slowly. That button gives you options for that. We have our position switch. Position 1 is generally going to be your dial adjustment for your Y and your X, your Z's, your R's, which the Z's, R's, all the auxiliary axes, the dial works on any mode, okay? But on position 1, it allows you to do that on your Y. So if you're trying to bump in a bend to a specific angle and you're just having a hard time fine-tuning that, you have that option in key position 1. Key position 2 is 95% of the time what you're running, and that's actually your standard operating mode. It has a fast fall to slow press once it hits the mute position, and then it automatically opens up when it's completed its bend. Key position 3 is slow up, fast retract up with your Y. This is if maybe I don't want to use my safety system that's on here, I'm going to turn it off because maybe I have a part that has a leg sticking up or a wall sticking up in the way of the safety lasers, and I need to go around that to make a bend, and it's moving slow so that you're still safe. You have time to move your fingers out of the way or any other objects when needed. Also on the control, we have an E-stop. This is not the only E-stop on this system. We have a pedestal E-stop, we have a control E-stop, and we have another E-stop on the electrical cabinet. We also have a light barrier on the back of this machine. And so that's if you're going to do maintenance on the back gauge or any of the auxiliary axes and you pass that light barrier, it's going to halt the machine from being able to move those axes to keep whoever is maintaining them safe while they're doing the maintenance. This machine has an NC start and an NC stop on the control. These are anytime you make an adjustment inside your CNC control, this is what tells the machine, okay, I've made any adjustments I need. Let's go ahead and implement that in my program or in my manual steps so we can go ahead and run that part. We also have a pedal down here. We've got the left pedal, which is your up pedal, and your right pedal is your down pedal, and it's also a two-stage pedal on that right side. It has an anti-panic switch in there to help keep you safe. So if you, God forbid, were able to crush your fingers in there, and let's hope that never happens, but if you were, rest assured you could push down that pedal to the second stage and get the ram to release your fingers and then get to the hospital or get medical help however you need. Okay? So safety has been taken into full consideration with this machine. We also have these side barriers here that can open up, and once these are open, because you're at a less safe condition and you're leaving something open, it actually switches over to slow press as well to make sure that you have time to get any obstructions out of the way before the ram hits it. And that's on both sides. So on this control, we have a couple different locations. We have your buttons across the bottom. This is the different pages you're on. Think of it as switching a book, okay? And then you have columns on your pages. Over here you have an automatically switch to the next step. You have running the same bend over and over and over again, which is your 1 with the up and down arrows, okay? And then you go down your first column. First column, the first line in there is one of your bend parameters, and it's method. You have multiple options inside method. You have air bending, which is going to be 95% of the time your best option for bending a 90 degree, 145, 135, all those 90 to obtuse angles, okay? Anything acute, you're going to use a different type of die, and we'll talk about acute dies in a little bit here. Also, you have bend bottoming. This means that you're going to actually push the material into the bottom of your V die, and so it's going to, another term for bottoming is coining. You're actually compressing the material to a certain amount to kind of compensate for spring back. Okay. Also requires 3 times the tonnage. So if you can avoid using bottoming or coining, you're a lot better off, and you're not stressing the material itself as much. Okay. Hemming. Hemming, a lot of people do foldovers. They'll do edge reinforcement where they fold over the edge so that it keeps it from being sharp. It gives it a little more structural strength. That can all be done with hemming. Hemming and bottoming is when you're going to be, that bottoming part of that is pressing it together. You're pressing your hemmed edge together so it's one solid unit almost. Okay. Next, bending length. This is not where the back gauge is. This is, if you were to draw a line down the bent part, if you were drawing it right down that bend line, how long would that be? So let's say we were bending a 24 inch by 36 inch piece, and I was doing a 24 inch bend. That would be my dimension there. It would be 24 inches bend length. Okay, product position. Let's go over that. Product position is a dimension that's based off the leading edge of the ram to the leading edge of whatever product you are bending. That's that dimension. It's more than anything for you to make sure you place your part where you're going to utilize your crown the best, and where you're going to make sure that your stations are set up and the right amount of force is going to each cylinder to give you a good part. So this is your best guideline for getting a good part, okay? Angle. We went to bottoming, and so what it's doing is it's automatically grabbing the angle of what that bottom tool is, right? Because we're planning on bottoming a part. If I was to switch this over to air bend, it's no longer going to restrict me to a certain angle. Now I can go, let's say if I'm trying to get a 145 or a 45 degree angle, it'd be a 135. And we always base this on what the inside angle is on our bent part. It's going to be 90. This is being a 135 or a 45 off of 180. And then in between. You could also do a 170 if you're just trying to kiss the material, or maybe you're doing a bumping. If you're doing a bumping sequence, then you might have something really shallow like that. Corrections. You have a correction alpha 1 and you have a correction alpha 2. Alpha 1 goes with cylinder Y1. Alpha 2 goes with cylinder Y2. These are corrections per each individual cylinder so that you can independently make corrections to your part. So if it's open more on one side than the other, I can tighten that up and make sure that they're balanced out and parallel with each other. Or you might even just purposely be leaving a part slightly open on one side other than, you know, from the other side because of a specific part you're trying to make. Y1 axis and Y2 axis, these are auto-calculated. So if you look, anytime I make an adjustment in my system, whether it's be material thickness, material type, tooling selection, it's going to automatically update this Y1 and Y2 axis based on the tooling, the material, and the angles I'm trying to achieve. Okay? These blue boxes mean, hey, I've been auto-calculated, and it's just letting us know, hey, we've just changed that based on our computations in the system. Those shouldn't be changed.
Oh, man.
Those will be automatic, and they'll be adjusted by those things I just listed, as well as any corrections you might be putting in to correct the angle that might be a little open or a little tight. And let's say if I was a little tight, I'd put a positive correction to open it up, and if I was a little open, I would put a negative correction to help close it up. Mute position. Mute position is where we do a fast fall to a slow press. That little section there where it transitions between is considered the mute position. And this is from the overall travel. So if I was 0, I'd come down to 6. So this one right now, our mute position's at 6.625. So 6 5/8 down from the top position, it's going to switch from a fast fall to a slow press. What also happens at this transition of speed is it mutes your safety lasers. So it's no longer looking for obstructions. So generally you're going to want to keep that mute position just enough to fit your material and any obstructions that you're understanding are going to be there. Anything you're accounting for. Opening. Opening is from after I've made my press and I'm down at the bottom, it's going to open up after each press, after each bend. That amount it opens above the mute position is considered your opening dimension. And that could be a 1 inch, 2 inch, a 1/2 inch, something really small. And it's just going to be right above that mute position. It's going to add that to it and give you a little bit of space. This machine's going to want to have some kind of opening on it, whether it's an 1/8 of an inch to 5 inch. And that's all going to be depending on what your part is. You might have a part with a really big back wall and you need to have that ram open up higher so you can slide your piece out easier. Force. This force is auto-calculated by our system. It takes into account the material thickness, the material type, the force required to make that bend, not to mention the length of it, positioning. It's going to automatically calculate force to make that bend happen. And then anything that you still need to make adjustments to would be a correction inside the system, which we have an alpha 1 and an alpha 2 correction location to do that. Dwell time. Dwell time is the bottom of the ram. When it comes down and it presses your part, it's going to dwell at the bottom of that press for just a certain amount of seconds, right? And I say a certain amount of seconds, but we're really looking at just a percentage of a second. So 0.1 second is the current dwell time on this specific machine, but that can be adjusted by whoever the operator is to what makes sense for their parts. One of the problems I run into out in the field is people do not pay attention to this. Instead of seeing a 0.10, they put in a 10 seconds. 10 seconds is a very, very long time, and you're going to think the machine's broken because it's going to sit there and sit there and sit there for 10 seconds. And that's going to drag. So that's one of the things I tell people, make sure that you're checking your dwell time. Someone didn't fat finger in a number because it will wait that 10 seconds or that 20 seconds, whatever you put in there, it's going to wait and it's going to drive you crazy. All right, Decompression. Decompression is the amount of distance after it's finished pressing, it's going to open up at a slower speed and then release. Most people are like, well, why would I have a decompression on there? One of the good reasons to use decompression is so that if I have something heavy that's sticking out the end, it allows me time to get that material down and settled before I pull it out or before it jerks on a crane or something you might be utilizing in your shop. So if I put a decompression of 1/4 inch, it's going to slowly open up for that first 1/4 of an inch and allow you to get hold of your material before it opens fast. Speed. The speeds that are down here is your speed. This is speed for pressing, the top one. And the second is the decompression speed. Like I was saying, when it opens up, you want that to be slower, right? So you can set that decompression speed to something really slow. If it's, say it's really heavy, maybe you need to get a crane latched on the end of it, something like that. You're allowing yourself time to handle that material safely. And then as for the pressing speed, you might slow that down. One of our customers slowed it down because they wanted to bump down the material little by little, and they wanted to do it without using the dial. They wanted to do it by foot. So we turned that down really low, and they were able to come down and just kind of slowly let off they'd bump, and then they'd let off their pedal, check their dimension, bump it again, check their dimension, and they were able to fine tune their bend. Wait for retract. This machine has built-in retraction to help protect the dimensions on the back gauge and to keep from damaging the servos, from the hardware on the front. A retraction is when that back gauge, let's say you're making a bend, well, there's a bottom edge on that bent piece of metal that's going to come up and clip the back of that finger if it doesn't move away. Retraction allows that finger to move out of the way, so after it pinches the material, finger moves, and it will bend up without running into the back gauge at all. Now, this function right here is saying, hey, if you do have a retract, do you want us to wait for the rest of the pressing after the pinch until that finger's moved out of the way, or do you want us to move it out of the way at the same time we're doing our press? Either way will work here, but you want to think about your edges and how much time you have for it to bend up to make sure you have enough time for that finger to get out of the way without it putting pressure on the finger. Or even flipping up the finger, because the back fingers are hinged and they will flip up if they're caught. It's a safety precaution so you don't damage your machine. Okay, so these safety features here, we've got safeguard mode, normal, and there's sometimes a tray mode in there. This machine does not have the specific type of laser system to use a tray mode, but if you were to have one with that protection mode, it's something to help you with box bending, to account for obstructions being in the way. Stop at mute. So we were talking about the mute position being where it switches from fast fall into slow press. If you'd like, you can stop in between that transition period. You can have the machine stop and then require a second press on the pedal. So you'd have to let off your pedal and then press again to come down. This might be useful for someone that's trying to position their part and they want that little extra time in there, want the machine to stop so they can make sure that it's settled and positioned the way they want it. That's everything in column 1. In column 2, the first things we see is the thickness. This is the thickness of the material. And this could be 1/8 of an inch. Right now we have 0.057 in, so pretty thin gauge. Material types. You have a material library of up to 99, and they can be programmed in-house by your engineer. Generally, you're going to reach out to your manufacturer of your materials, whoever's supplying you your steel, your aluminum, and make sure that you have the right tensile strength, the right hardening component, and the right E-modulus on that material, so that when you make your bends, they're as accurate as possible. As for right now, we've got 6 items in here. We've got rough steel, we've got aluminum, we've got galvanized, titanium, stainless steel, and zinc. As for our punch right now, this is your tooling. This is your fingers that are in there. You've got your dies, your adapters, your punches. It's all the tools you're using to make your part, and you're going to select the right tools to make the kind of part you're doing. So if your drawing says that you need to have a 1/4 inch radius, you're going to try to find a tool or a punch that's going to allow you to hit that radius. As you see here, these are all grayed out. You can't change these here, but that's because over here in your command window, you have another button for that, which we will cover later. Auxiliary axes. The auxiliary axes are your X's, your Z's, your R's. Your X is from forward to back on the machine, your R is up and down, and your Z's are your finger placement from left to right. And you've got, on this machine, you've got 2 Z's, you've got 2 X's, and then you've got a single R. As for each of these auxiliaries, so whether it be X, X5, Z1, Z2, they each have a retraction availability, like we were talking earlier, to move the fingers out of the way so they don't get clipped by geometry on your part. You have those options on every single one of your auxiliary axes to move them out of the way so they don't come into a hazard from your part bending. Also, you can adjust the speed on those retractions per auxiliary axes as well.
Okay.
After we go through all of our auxiliary axes, we come down here to the very bottom where we have deflection. This machine has a built-in automatic crowning. So if you've ever bent using a press brake before, you've noticed on longer parts, it can canoe in the middle, where the inside angle in the middle of that long part will be more open than the outsides because it's fighting more material when it's on the inside bend, okay? This crowning automatically, the motor that's on here, automatically pulls wedges together so that it creates this crown shape. It's going to automatically apply a crown to this bottom adapter here, allowing you to take out that bowing in your material and give you a more consistent angle all the way down the part. The other thing this helps with is it keeps your part from creating a bow. That's automatic, but it can still be adjusted via corrections when needed. On this far right side, we have our command window here. The top button on the command window is main. This is the page we just went through. This is where you adjust the majority of your settings. 2 is macro, and it's going to show you what's programmed and what the actual position is of each of your axes at this particular time. Manual positioning. This is what we talked about earlier, where you can use the dial to move your different axes in different locations. You would select the axes you want to move, and you would roll your dial in and out to move either the X in, the Z left to right, or maybe the R up and down, just because your part might need, maybe has a little lip that sticks up on a shoulder, you need to support it. It gives you those options. That's all of your manual. You can also manually adjust your deflection for crowning if needed. I don't see a lot of need for that, but it does allow you that option. Correction. This is the actual correction area. We earlier talked about an alpha 1 and an alpha 1 and an alpha 2 correction, okay? Back here you have corrections for all sorts of things. So let's say maybe your part's got an X-axis programmed at 5 inches back. So your back gauge is 5 inches back from the center of the die. Here, let's say you make your first bend and it's off by about 1/8 of an inch. You can make a correction in there and have it hold that correction on that part. And maybe you're going to do that on the next bend and the next bend, and you want that offset. This allows you for offsets in all the different axes, whether it's the Y-axis, the X-axis, the X5, the R, the Z1, Z2, and even in the deflection. Down here at the bottom, we've got reset angle corrections. This allows you to reset whatever you used in the past program and start fresh. You also have a calculate corrections button. This is one I share with everybody. Depending on how long your part is, it's going to give you 2 to 3 options. If it's a shorter part and the machine's not expecting to require a crowning involved or deflection involved, it's going to give you an alpha 1 and an alpha 2. If it does require deflection, it's also going to give you a center dimension, which you would grab and you'd measure your part, you check your angle, and then you would put in a correction. So let's say I was trying to make a 90-degree part down the whole length. If I was a 91 on one side, a 91 on the other side, but then in the middle I was 93, so I was a little bit more open, I would do a -1 correction on alpha 1, -1 correction on alpha 2, and then in the center I would do a -3 to get rid of my bowing, my canoeing. That is your correction calculator. Once you've made your adjustments, you're going to hit accept. It will automatically update your correction chart, your table. Tooling setup. Earlier I showed you how all those tools were grayed out. That's because you have a specific window for adjusting your tools. In here you can select your punches and you can put a large library of different punches that might be useful for your company. You would select the one you're going to use, you would change your length, your position, your orientation, whether it's got a heel or not. This would be considered a heel. It allows you to do tight corners on like boxes where you don't want the sidewall rubbing against the tool. It allows for that to pass without rubbing anything. It also allows you to do for undercut edges. The second tool in here, dies. Again, you can put in a really deep and expanded library in here if needed. Just depends on what is useful for your company. Adapters. You might have a punch adapter. You might also have a lower adapter. Depending on what your company uses, they might have multiple variations of adapters. You might need to have offsets put in, or maybe you're going to have an extender put in because you need to have an extra deep draw on something. Those are all done through this adapter area. If you get to your machine and you want to decide you want to delete all your tools and start over fresh, you can hit your delete button at the bottom here, delete the whole configuration and start over fresh. Also on this page, you can add tooling. So let's say I needed to add more stations, okay? I can click up in here and I can drag this over a little bit so I can move my tool off onto the side. And if I need to, I can add another punch. So add punch. I want the same type of punch because you want to make sure that all your tooling across is the same. Otherwise, you're going to run a risk of collision, and you don't want collision on any of your tools because tools are not cheap. So maybe on my second set here, I'll put in like a 2 because I want a really narrow station. And then for my bottom die, I'm going to do the same thing. I'm also going to add a 2. Add a die and also do a 2 for that as well. Right aligned with each other. Now I've got 2 stations and I can move things around to where they make the most sense. So if I was to bend a long piece, I'd want it in the center so I can better utilize my crowning system. And then maybe on this 2-inch, I'd give it a little gap so I can maybe run a wall up there, or if I have some geometry that's got to stick out the end. And then as you can see, I can just drag it until they line up. See those red lines popped up? That just means you're aligned properly. And that's my tooling. I've got 2 stations. I've got the same dies and same punches in both stations, so I don't have to run the risk of a collision of tooling. And I've got my setup ready to go. Shift product. This is so that if you have a part that's maybe 13 inches, you can choose where you're going to have it drag. You can shift it right, and it's kind of hard for you to see me shifting it, but little by little, it's moving over when I hit shift right. Same thing if I do shift left. Or I can do jump left, which moves it over to the other station. Jump back right, jump again, maybe drag it over. I can either use those shift buttons there, or I can just tell it where I want my part. I want it right in the center of that die because I want to make sure my crown is perfect. Accept. That's your shifting product. You also have a shift gauge. If you look at your back gauge, you have multiple locations where your fingers can rest. If I do lay on finger, the benefit of this is so that you can have support for your part. I can do 0, which is the front edge, 1, which is the first shelf, and 2, which is the second shelf. And then it will go right back to 0 again. This allows you to do support for your part, allows you to use some of the geometry of the back finger here to either cup a corner of a part, to give you a little bit of better control of where your part is placed on the machine. As you can see, this has 3D options. So if I take it from profile down to 3D, I can see exactly how my part is laying. You might have seen that some of these things popped up. Some of these new buttons popped up that weren't there before. I can select a finger, and then I can do something like pinch corner. and it moves that finger down to catch the corners so that I have better placement of my tool. So instead of just resting against the back, I'm actually going to put my part into the corner of the finger so it catches that little corner there and holds it in place from left to right. You can do the same thing on the other finger, and now I've got a fully locked part, and as long as my parts are accurate in length, I'll be able to place that part and make the same bend over and over and over again and be assured that my part's in the center of the machine because I've lined up in between my fingers. Again, we can use Gauge Wizard. We've already gone over that. We have shift left, shift right, lay on finger, and then you can change fingers. Let's say you had a library of fingers. You could change the finger type. You can also just click here to select back and forth between the left and the right fingers. Hit accept. That's where I have my part lined. That's all of your command window. The one button I haven't gone over on this main page is Diagnostics. If you ever have an issue with a axis, or maybe your machine is stopped and it just seems like it keeps thinking, you can open up this diagnostic window and it will tell you what it's thinking about. It will say, hey, I've achieved my x-axis. I've achieved my fifth axis. I've achieved my r-axis, my z1, my z2, my deflection's met. Or we'll say still positioning. And if it's still positioning, maybe there's something that you've got on that machine that it's unable to achieve because maybe you've put in something incorrectly, or maybe there's something in the way. And so this just gives you a guideline so you're not sitting there pulling your hair out trying to figure out what's wrong. All right, we just covered all the manual page on this Be Genius here. If you have any questions on how this runs, or you'd like to have a demo, reach out to the service department or the sales crew if you'd like a demo done on this machine, and I'm excited for you guys to try this out.